Welcome pre-calculus students to class today on Tuesday the 17th. Hope you guys are doing well. Hope you're ready to review some math today. Those that have not turned in their Chapter 8 test, please get in touch with me about that. Get that turned in as soon as possible. And if you need some help, do not hesitate to contact me, okay? I've got someone coming actually this Thursday to get some help. So that is available to you, so please don't hesitate to do that. Also, one student has contacted me and told me they will be taking their exam here at my house. That is your choice, but be ready to make that decision and let me know as soon as you know. I'm sorry, as soon as you know. Excuse me. Okay, let's take a look here. This is test number 1. Know these 6 definitions. Know all of this stuff here that we went over. I'm not going to read it, of course, every day. Test number 2, we talked about these 12 topics right here. So make sure... Not sure what happened there, so hold on one second and I'll fix that. Here we go. Know these topics right here and you're responsible for those. Test number 3, we talked about these 8 topics. Make sure you can, I'm not doing that, guys. I think my pen is kind of going crazy here. Hold on a second. Make sure you understand how to work problems with those 8 topics. Moving on to number 4, be able to find arc length, radius or central angle, graph sinusoids, factor tree expressions, and know how to use those identities listed. That's test number 4. Test number 5, I've broken that down into steps for you. Be able to solve inverse trig problems, sometimes combined with regular trig functions. So make sure you can do those. Number 2, be able to prove trig expressions. We had 2 of those yesterday on the test review. Be able to use product to sum and sum to product identities. And I think that's it. These tests have become shorter and shorter, and I'll tell you why. Number 1, I'm not big on giving word problems on the final exams. I'm big on testing the fundamentals of what you needed to learn. And so some of those problems have been left off. Also, there was a couple tests there that were pretty short, and so we're seeing that now as we go over these tests. All right, let's continue on. All right, let's go ahead and start reviewing test number 6. Test number 6. So if you have that, please feel free to get that out of your notes. And if you don't have it, just follow along. That's totally fine. Okay, let's look at 4 problems here. Solve problems 1 through 4. Be sure to include all answers in the domain 0 to 2 pi. All right, let's go ahead and get started with the first problem. 4 cosine squared equals 3. Now, here we go. First of all, we're solving for x, and of course the cosine and the x go together. So the good thing to do, or the smart thing to do, is get the cosine all by itself. So I'm going to divide both sides by 4. Divide this side by 4, the 4's cancel, and divide this side by 4. So cosine squared equals 3/4. Now next I want to have just cosine, so I'm going to take the square root of cosine squared. The square root of cosine squared is cosine, but if I take the square root of one side, I must take the square root of the other side, so plus minus square root of 3/4. Now we can simplify this square root of 3/4, and I'm going to do that for you right over here. Okay, so watch carefully, please, what I do. That's not going to work. Watch carefully what I do to this. First of all, the square root of 3/4 is the same thing as the square root of 3 over the square root of 4. Next, I do know the square root of 4, and it is 2. So next I have square root of 3 over 2. So finally I have cosine of x equals plus minus square root of 3 over 2. All right, so simple enough. So I've gotten cosine all by itself, and now the next thing I say is, well, I've got to find that angle. I've got to find the angle that when I take the cosine of it, it gives me square root of 3 over 2. Now, I'm not going to pull your table up, but if you'll look on your table, you'll see that the cosine of 30 is square root of 3 over 2. So I know the angle here is 30 degrees. Now, hold on a second. Remember, I want to know the positive and the negative. So what I'm going to have to do is actually, in this case, I'm going to have to draw triangles in every quadrant. Because think about it, cosine is positive here, negative here, negative here, and positive here. So I've got to consider all of these answers that when I take the cosine of these angles, it would give me square root of 3 over 2, positive and negative. So I start here and I draw to the first, and I draw or rotate to the first hypotenuse, and that's going to be 30 degrees. So there's one answer. And then I've got to rotate to my next hypotenuse, and that's going to give me 150 degrees. Then I've got to rotate to my next hypotenuse right here, and that would be 210 degrees. And then I would rotate to my last hypotenuse right here, and that would be 330 degrees. So all four of these answers are necessary to solve this equation. Now, the only problem with my answer that I have there is, notice my domain was given to me in radians right here, and so really my answer should be in radians. So my answers would be pi over 6, 5 pi over 6, 7 pi over 6, and the other one I think would be, let's see, 1 5/6, 11 pi over 6, I believe. All right, so there's your four answers to that one. So we isolated the cosine squared, then took the square root of both sides, and then found the angles that would satisfy this trig equation. Okay, let's move on to number 2 now. Here's number 2. We have 2 sine squared x equals square root of 2 sine x. Now, as soon as I see that I have a sine squared and a sine, that would be very similar to having an algebra equation like this. 2x squared equals 3x. And for me, I would bring the 3x over and make it a negative 3x and get one side equal to 0, and then factor. I would pull an x out, and that's the same thing we're going to do here. Okay, so what I'm going to do is I'm going to bring my square root of 2 sine x over and make it negative. So now I would have 2 sine squared x minus square root of 2 sine x equals 0. And now I'm going to factor out, I have a sine squared and a sine. So I know I can pull one sine out for sure. So I'm going to pull a sine x out, and I'm left with 2 sine x, because sine times 2 sine is 2 sine squared. And then over here I'm left with negative square root of 2, because sine times negative square root of 2 is negative square root of 2 sine x equals 0. And now I'm going to take each group and set each group equal to 0. So my first group of sine of x equals 0, and my other group is 2 sine x minus square root of 2 equals 0. Now over here, do understand that sine is already all by itself. So I'm simply looking for an angle that when I take the sine of it, I will get 0. Now, that's not on our table anywhere, and so what we're going to have to do is we're going to have to use our calculator. So when I hit second sine of 0, I get out 0. So I know that when I take the sine of 0 degrees, I get out 0. But 0 is called an axis angle. It lies right on the axis. So I'm going to have to try the other axis angles also, like the sine of 90 does not give me 0. The sine of 180 does give me 0. That works. So there's another answer. And then the sine of 270, so sine of 270, and that gives me negative 1, so that doesn't work. So the sine of 0 is 0, and the sine of 180 is 0. So there we go. Very quickly converting these to degrees, I would have 0, and I would have pi. So there's two answers right there, and I can go ahead and move those up top here, and they will go right here. Now we have some more answers coming. Now let's take a look at our other group that we set equal to 0 right here. Well, first of all, I'm going to bring the negative square root of 2 over and make it positive, and then I'm going to divide by 2. So I should end up with this right here. Sine of x equals square root of 2 over 2. Bring this over and it becomes a positive square root of 2, and then divide both sides by 2 and you will end up with square root of 2 over 2. Okay, now if you'll look on your table, you will see that we have square root of 2 over 2 on our table for sine. And if you'll look, it's the sine of 45. So I know the reference angle is 45 degrees. Also notice that I want to get out a positive square root of 2 over 2. So I'm thinking, where are the two quadrants that sine is positive? Well, sine is positive here, and sine is positive here. So I take my reference angle, 45 degrees, and I'm going to write that inside both triangles. Okay, I'm going to rotate up to my first hypotenuse, and that's going to be 45 degrees. So there's one answer. Then I'm going to rotate to my next hypotenuse, which is right here, and that's going to be 135 degrees. Okay, and I'm going to have to stop right there at that hypotenuse. So if I wrote these in radians, 45 degrees would be pi over 4, okay? And 135 degrees would be 3 pi over 4. Okay, so there we go. It's just that simple. Students getting the sine function all by itself, and then finding the angle that would give you the correct answer. Okay, so not too difficult. All right, let's take a look now at 3 and 4. They get a little more difficult now, but let's see if we can't tackle these and do pretty well. First of all, on the test, if you'll look, you'll see we crossed this off, and we said that's not supposed to be there. That was a typo by Mr. Earhart. So we have cosine of x plus sine of x equals 1. So cosine of x plus sine of x equals 1. Now this is going to be a really difficult problem to solve because first of all we notice there's no substitutions that we can make. We see that right off the bat. And then number two, there's really no factoring we can do because we have a cosine and a sine. They're two totally different trig functions. So what I suggested is we go ahead and square this entire side. But if we square one side, we must square the other side. Now trust me, when you have cosine x plus sine x times cosine x plus sine x, you're going to get out a pretty long expression. In fact, I'm going to go ahead and write that down now. You're going to get this right here. You're going to get cosine squared x plus 2 sine x cosine x plus sine squared x equals, and then 1 times 1 is 1. Okay? Now, not too bad. We're doing fine. I do notice right away I have that good old sine squared plus cosine squared. So I'm thinking to myself, this looks pretty messy, but if somehow I could move this term right here, this sine squared y, or x, excuse me, and move that to right here, and of course the plus sign should go, well, we'll just go like this, and there should be a plus sign here. So if I could move that sine squared over to here and then put equals 1, just erase this. Now what that has done for me is, look students, I now have sine squared plus cosine squared, and this whole expression from here to here, if you'll look at your Pythagorean identities, it equals 1. So now I have 1 plus 2 sine x cosine x equals 1. And then if I bring this 1 over and make it negative, I'm left with 2 sine x cosine x equals 0. Now, if you'll look at your double angle identities, please pause and look at your double angle identities. You will see that the sine of 2x equals 2 sine x cosine x. So this entire expression right here can be substituted out with sine of 2x equals 0. So there we go. We did all that work to break down this entire equation to this right here. And there it is. So now we're going to take this and we're going to solve this, okay? So here we go. Now the only problem, it looks pretty easy, and I'll admit that it does, but the only problem is this 2x right here. I'm going to get that in just a second, okay? Now, sine of what angle gives me 0? Well, there's no 0 on my table. You'll see that, okay? So I'm saying to myself, if I hit second sine of 0, I'm going to get out 0, and if I check my other axis angles, I'm going to see 180 is another answer. Now the problem is that means this entire angle right here is 0, okay? And it also means this entire angle right here is 180 degrees. Those are the two angles that when I take the sine of them, I get out 0. All right? So here's the problem. I want this entire angle to be 0, so I'm going to have to say 2x equals 0, that entire angle, divide both sides by 2, and x equals 0. Then I'm going to have to add 360 degrees to 0, because we all know you can go around another revolution. So now I have 2x equals 360 degrees. Divide both sides by 2, and x equals 180. Okay, so I'm kind of finding my x values here, and notice how they're all falling in between 0 and 2 pi. Okay, now if I went any further than this, trust me, I would get out an answer larger than 2 pi, so I'm going to stop there. Now I've got to consider my 180 degrees. I considered my 0 degrees right here, and I added 360. Now I'm going to try my 180. So 2x equals 180 degrees. Divide both sides by 2, and x equals 90. So there we go. Now I'm going to add 360 to 180, and I'm going to get 540. Then divide both sides by 2, and x equals 270 degrees. Now if I go a step further and add 360 to 540, I will get out an x value that's way outside of my domain. Remember, all of your answers have to fall between 0 and 2 pi. So these are your 4 final answers, and of course they should be written in radians. So it would be 0, pi over 2, pi, and 3 pi over 2. So there we go. There are the answers to number 3. And now one more to go. And just to encourage you, we have one more to go, and then one more slide with 4 problems on it, and that's it. We're just doing 2 slides today, okay? So they're longer problems, but it's just 2 pages. Okay, let's take a look at number 4, and we are cruising right along. 2 tangent of 2x minus 2 equals 0. Well, it seems to me like I'd want to get tangent all by itself, tangent of 2x. So I'm going to bring the negative 2 over and make it a positive 2, and then divide both sides by this 2 right here. So I should end up with the tangent of 2x equals 1. Bring the negative 2 over, it's gone. It becomes a positive 2, and then divide by 2, so these cancel, and divide by 2, and you get 1. So tangent of 2x equals 1. Now, if you'll look on your table, you're going to see that the tangent of an angle giving you 1 is on your table. It is. And the answer is 45 degrees. So let's think this through. We want to know tangent of a certain angle that gives me out a positive 1. So tangent is positive here, and tangent is positive here. So I'm going to put a 45 degrees here and a 45 degrees here. So this whole angle right here, 2x has to equal 45 degrees. This whole angle does. And also this whole angle 2x has to equal, well, 180 plus 45 more, 225. Okay, so there we go. So now I know the 2 angles that I'm going to use. Now I'm going to divide both sides by 2, and one answer is 22.5. 0.5. Then remember, we're going to add 360 degrees to 45. So 360 plus 45 degrees would be 405 degrees. And let me look at my answer sheet here. And hold on one second. And we're going to get 202.5. So here's one answer. Here's the other answer. All right. Now let's take a look. Hey guys, I'm doing a video. Hey guys, tone it down, please. Thank you. Sorry about that, pre-calculus students. Okay. 2x equals 225. So x would equal 112.5. Divide both sides by 2. And then we're going to add 360 degrees to 225. And we're going to get 585. And we're going to divide both sides by 2. And x would equal 292.5. This is not easy stuff that we're doing. Now I cannot do these radians in my head, so I'll just do one for you and you can convert the rest on your own. I don't care what the degrees are. Remember how to convert these to radians? You always put the degrees over 1 and you multiply it by pi over 180, always, okay? So 112.5 times pi would be 112.5 pi over 1 times 180 is 180. It's always weird to have a decimal and a fraction, so if I were you, I would move this over one place. You can do that as long as you move this one over one place. So I would end up with 1,125 pi over 1,800, but I'm sure that can be reduced, and your calculators will do that for you. So hold on one second. I'm going to type that in my calculator real quick. And what you're going to get is 5 pi. So this whole fraction reduces to 5 over 8. So it would be 5 pi over 8. And you can convert the rest on your own, but that's how you would solve this, okay? So I hope this is making sense. We've reviewed how to solve these different trig equations. Make sure that you're familiar with these. Make sure you know how to use your reference angles. And let's go ahead and continue on to solving triangles using law of sines and law of cosines. And then we'll be done for the entire video. So not a very long video today. Okay, let's see if we can't make a little sense out of these problems. First of all, I encourage you guys to always get a little picture of the triangle. It does not have to be drawn to scale whatsoever. I draw mine the same every time like that, and I just say A, B, and C. Now, according to this, side A is 15, so here's angle A, go straight across. This is 15. Side C is 7, so here's angle C, go straight across. Here's side C. And angle B is 62 degrees. Now here's how I've taught you to solve these. I've told you, first of all, always check to see if you have side angle. If you have side angle, that's the one kind of ambiguous case where you might have 0 solutions, 1 solution, or 2 solutions. And so you have to be really careful and always check for side angle. Please don't forget to do that on your test. But in this case, we have side angle side. So far so good. The next thing I taught you to do is anytime you have two angles, like pretend this was 50 degrees, which it's not, but if it was, couldn't we find this third angle really quickly? Sure we could. Add these together and subtract from 180, but in this case we don't have that. But always check and see if you have two angles so you can quickly find the third angle. And then lastly, see if you can use law of sines. Now in order to use law of sines, you have to have a pair. Well, I don't have a pair here. Here's my angle, but I don't have a side over here that I know. I know this side, but I don't know this angle. I know this side, but I don't know this angle. So you cannot use the law of sines. So we're going to have to use the law of cosines, which is too bad. So whenever you have side, angle, side, you always want to try to solve for this opposite side first. Of course, that's going to be little b. So we're going to solve for little b. So we're going to have b squared equals 7 squared plus 15 squared minus 2 times 7 times 15 This should be familiar if you remember the law of cosines. Cosine of 62 degrees. All right. Now, let me look at my notes here. I've already typed this into my calculator ahead of time, or on an answer sheet here. And so I know that when I type this entire expression into my calculator, I'm going to get out 175. And then when I take the square root of both sides, I will get b equals 13.2. 13.2. So I'm going to come up here and real small for side B, I'm going to write 13.2. All right, so good enough. Now we're cruising right along. We have found one side. I'm going to come over here and put 13.2. Now in your notes during the school year, if you'll think about it, I told you the safest thing to do was to always use the law of cosines to solve the rest of the triangle. And the reason I said that is I did not want to get into a bunch of extra side notes, but we've done so many of these now. I think you can handle this. You can use, once you have a pair like we do right here, see how we have a pair right here? Since we have a pair, 13.2 over the sine of 62, you can use the law of sines under one condition. Always find the smallest angle first. Always. So we know we're missing this angle, and we know we're missing this angle. Find the smallest angle first. Well, Mr. Earhart, how do I know which angle is the smallest? Well, remember the smallest angle will always be across from the smallest side. And so here's 7 and here's 15. 15 is bigger than 7, so that means this angle across from 15 is going to be bigger than this angle over here. So you can use law of sines as long as you solve for the smallest remaining angle. Out of the two remaining angles, solve for the smallest one. So we are going to have to solve for C because that's the smallest angle. So I'm going to have 7 over sine of C. And if we cross multiply and then divide, we're going to end up with, now think about it, we're going to end up with, well, first of all, 7 times sine of 62 is 7 sine 62. And then if we took 13.2 times sine of C, we would have 13.2 right here. But then what we would do is we would divide both sides by 13.2 to get sine of C by itself. And so let me bring that over here if at all possible. So we'd bring that over here. And so what we have is 7 sine of 62 divided by 13.2. Now let me look at my notes here. If you type that in correctly, you're going to end up with sine of C equals 0.4682, and then take second sine of 0.4682, and you will get 28 degrees. So C is 28 degrees. So 28 degrees right here. And now, can I not very quickly find the third missing angle? Sure you can. I'm going to add 62 plus 28, and I'm going to get 90. And so 180 minus 90 is 90. So angle A is 90 degrees. Now, do you see how angle A does not look anything like a 90-degree angle? And that's totally fine. Remember, we do not try to draw our triangles to scale. That's not a big deal. And so in this case, we're totally fine. All right? Okay, let's go ahead and let's solve for number 6. Number 6. Here we go. All right, I've got my triangle already drawn, so we'll go A, B, C. Little a is 1.5, little b is 2.5, and angle A is 58 degrees. Now the first thing you do is you check, do I have side angle? And yes, you do. Look, you have side, then a side, then an angle, or angle side, however you want to say it. It doesn't matter as long as you realize you've got this situation where there could be one solution, two solutions, or no solution. Okay, and so please keep that in mind. Now I'm going to go ahead and tell you this right now. I'm going to show a little, sorry for yawning, I apologize. I'm going to show you a little leniency on your exam here. I'm not going to give you a problem that has two solutions when dealing with side angle, but I will give you, I very well could give you one that has one solution or I could give you one that has two solutions. Okay, I mean no solution, excuse me. So keep that in mind, and don't be surprised if you get out no solution as you solve this. Okay, and if you get out one solution, that's fine. So here we go. The first thing I've taught you to do is to check for side angle. We know we have that, so we're going to be cautious. Number two, I want to see if I know two angles. If I know two angles, I can find the third angle quickly, and no, I do not. And then number three, I'm going to see if I can use law of sines. And look, I can. Here's 58 degrees and 1.5. 58 degrees and 1.5. So I can say 1.5 over the sine of 58 degrees equals, and now here's the two angles I'm solving for. Remember, when using law of sines, always find the smallest angle first, always. So I'm going to go with, let's see, well, the problem with that is I don't know the length of the side across from angle C right here, but I do know this one here. So in that case, since we're not sure which one's going to be the smallest, and you can pick either one, that's totally fine. So we're going to go with, let me look at my notes here. We're going to go with 2.5, and we're going to find sine of B. So we're going to say 2.5. and then sine of B. Now if you cross multiply and then divide, obviously you would have 1.5 sine of B equals, and then you would have 2.5 sine of 58, but then don't forget what we're going to do is we're going to divide both sides by 1.5. So there we go. Sine of B equals 2.5 sine of 58 over 1.5. Now, if you type that into your calculator correctly, you're going to get this. Sine of B equals 1.4134. And when you type that into your calculator in a second, when you hit second sign and this number, you're going to see you're going to get out an error or cannot be done or no solution or whatever. And so right away you know this angle B does not exist. And so this is going to be one of those side angle problems that has no solution. So there is no solution to that problem, okay? All right, let's continue on and take a look at number 7. All right, what do we have here? We have angle A is 91 degrees, angle B is 42 degrees, and angle C is 47. Now the first thing I've taught you to do is see if you have side angle, and obviously we don't. We have angle, angle, angle. Number 2, you want to quickly see if you know two angles so you can find the third angle quickly. And then number 3, we try to use law of sines and we can't. But you know what, students? You cannot even use law of cosines on this. Do you remember what I told you way back at the start of this? That in order to solve any triangle, you must know 3 parts. And out of those 3 parts, you must know the length of one side. You must. So you must know 3 parts, and one of those 3 parts has to be a side. Well, look, we have 3 angles. We do not know the length of this side. We do not know the length of this side. And we do not know the length of this side. No solution, or cannot be done. Okay? Because if you think about it, just because you know the angles inside the triangle, let me see if I can expand this and show you a little bit. Look, watch this. Just because you know the angles inside of a triangle doesn't mean that you can find the sides, because you can keep the angles the same and make that triangle longer and longer and bigger and keep the angles the same, where you could make it really small and you could actually keep those angles the same and shrink the sides. So you cannot solve a triangle unless you know 3 parts, and one of those 3 parts has to be a side. So now we're going to move on to number 8, and it's our last problem for the day. So good job. Hopefully you've listened well, and we're just about finished. Okay, we know side A is 5, we know side B is 6, and we know side C is 2. Okay, step 1, make sure you don't have side-side angle. If you do, proceed with caution, but we do not have side-side angle. Number 2, see if you know 2 angles so you can find the third angle quickly, and you don't. Number 3, try to use law of sines. Well, you can't because you don't have a pair. You don't know what this angle is to go with the 5. You don't know what this angle is to go with the 2. And you don't know what this angle is to go with the 6. So you cannot use law of sines. So we're going to have to use the law of cosines. Now, students, it doesn't matter. You do not have to find the smallest angle first when using law of cosines. Okay, law of cosines doesn't matter. So just out of the blue, no certain reason, I just chose to solve for angle A first. That's just me. You could have solved for another angle if you wanted. So across from A is 5. So what you would put is 5 squared equals 2 squared plus 6 squared minus 2, and then a 2, and then a 6, and then cosine of, well, I had 5 here, and 5's across from A, so cosine of angle A. Now be really careful with your work here, okay? Watch what I do. 5 times 5 is 25, 2 times 2 is 4, 6 times 6 is 36, okay? And now, negative 2 times 2 times 6 would be negative 24 cosine A. Now, a lot of students like to take all three of these numbers, 1, 2, 3, and put those three numbers together. Well, I have no problem with you putting these two numbers together. That's fine. But you cannot put these two numbers with negative 24. It's being multiplying. The 24 is being multiplied times the cosine. So this is one term over here. It's an unlike term. You cannot combine 24 with the 36 and the 4. That's a very common mistake, and you cannot do that. Well, 4 plus 36 is 40. Now I'm going to bring the 40 over and make it a negative 40. And after I've done all of that, I'm going to end up with negative 15 equals negative 24 cosine of A. Now we're going to go ahead and divide both sides by negative 24, and if I do that correctly, a negative divided by a negative is a positive, and 15 divided by 24 is 0.625 equals cosine of A. Now hit second cosine of 0.625 and you will get 51 degrees for angle A. 51 degrees. So I'm going to come up here and I'm going to put 51 degrees for angle A. 51 degrees. Now, in the past, I encourage you to use law of cosines, but you can use law of sines as long as you solve for the smallest angle first when you can. So I've got angle B and angle C. Notice angle B is across from a 6 and angle C is across from a 2. Obviously 2 is smaller than 6, so angle C is going to be smaller than angle B. So with that in mind, I'm going to solve for angle C first. So I have 5 over the sine of 51 equals 2 over the sine of C. Now if we cross multiply, we're going to end up with something like this. 5 sine of C equals 2 sine of 51. And then we're going to divide both sides by 5. Divide both sides by 5, like that. So there we go. And so if you type that into your calculator, you're going to end up with a decimal. Sine of C equals, hold on one second, let me check this out here. Sine of C equals 0.2517, and if you type that 2517, and if you type that into your calculator correctly, you will get 75 degrees for C. 75 degrees. So with that in mind, now I can find this third angle so quickly. 51 plus 75 is 126, and if you take 126 and subtract it from 180, you're going to get 154 degrees, or excuse me, I apologize. It would be just not 100, but just 54 54 degrees. 54 degrees. Okay, so there we go. That's how you solve triangles. I hope this review has been a help. Not a lot from this test, but be thankful. It's not a super long video. Call or email if you have any questions. And I hope you're working diligently on preparing yourself for this semester exam.